Damn. It is now 6:20. I got slumped. Oh. Looking up that nap research real fast just to see if napping is cool, what the health stuff shows. Shows the people who nap probably nap because they got fucked up sleep. People who nap probably got fucked up sleep. So people who nap probably don't have as good health benefits because they get fucked up sleep. So sleeping more doesn't help enough because they get fucked up sleep. Unless you get tiny naps. Then it's just to supplement your natural sleep, maybe. So maybe you're okay. Okay, let me see what I last did real fast. Oh, that's now. Maybe? Yeah, that's definitely now. Hello? That's all I've done? Hour and a half of work? Alright, I gotta lock the fuck in. Let's get it. Oh, I did not mean to fall asleep for so long. When did I? Let me find out when I posted that real quick. Yo. When? 4 hours ago. Oh my. Oh, I fell asleep for 4 hours. Wow. Oh, excuse me. Okay. It's back to 4 statements, 4 loops. Please, get the fuck out of my eye, bro. Okay. Okay. Alright, I'm ready. Oof. Alright. Why is this so close? Okay. Yep. That makes sense. We have all the shit built in right into the line of the for loop. I don't have to declare stuff before and then put it within, or define stuff before and then put it within its own scope. Like I don't have to say int whatever int or int fucking counted bullets and then int total bullets, and then we set this to be bullets in magazine, whatever. So in this case, we'll just say 30. Or in bullets in ammo box. 30. Excuse me, and then while counted bullets is less than bullets in ammo box. This can be const expression because we're not changing it. And for compiler optimization, this, and then we need input and output. Rather, we need output for printing number of bullets. Cool. Oh, this needs to be less than or equal to. Counted bullets. Oops. Cool. Cool. There are 30 bullets in this little ammo box. I have my hand and no bullets in it. I count. Well, I don't have any bullets. And then let's start. And maybe I start at 1. But yeah, cool. Instead of doing that, we can just know we need output. Now we can just say for, I guess for now we might just say int const expression int bullets in ammo box 30. Oops. For counted bullets of 0 while, bro, oh, it's not, I didn't give it a data type. While counted bullets is less than or equal to bullets in ammo box. And then we will count 1 bullet. Like that. Bro, you need another type? What are you bitching about? Missing type specifier. For what? Huh? Oh, motherfucker, I just did const expression int, or const expression. Okay, cool. Yeah, that's easier. It's all on one line. It's obvious. This is what we're using to count the shit. This is the condition that determines whether that we run to determine whether the loop should activate or not. This is what we do afterwards to determine whether it will run again in the future. This is the logic that actually runs. Boom. It would be cool if I could also have max bullets within the for loop as well. But maybe that's not a good idea. Maybe I want other variables to be from outside in higher level scopes than that. That way I can go to, well, I could do it either way. Maybe it would be cool if I could define them in the loop at the same level there. That way I don't have to define them within the loop itself, within the loop statement, because then we'd have to create max bullets in ammo box 30 every single loop. So we do it 30 times, 31 times, because we're counting and we don't have any at first. Our first count is 0. So it'd be cool if I could do max bullets at the same line, but we'll see. I don't know if I can. But I could also do it outside of it. That way, I mean, I can always do that. But I could have a namespace that is items, and one of the items is an ammo box. Maybe it's an object, and it has an amount of bullets that are in it. Okay. Mm-hmm. Mm-hmm. Oh. Yeah, I guess that's what we would call loop variable modifier, because that's what determines it. A loop variable is compared inside is evaluated within the loop condition, or evaluated as an operand, or rather, the loop's condition includes the loop variable, and when evaluated, determines whether the loop executes or not. And the loop variable modifiers determine whether the condition is true or false in the future. To calculate integer exponents. See standard int for the big buoyants? Yeah. Oh, yeah, it's easy enough. Yeah, we're just multiplying it by itself until we get that. So ones for each. So if we do power of 2, okay, so we could pass in, um, let's just say 5, 5, and 3. So 5 times 5, 25 times 5, 125. So we say 5, or hold on, here we go. So total, oh yeah, because, well, you could do it either way. You could do it either way. But in this case, let's see, hold on. I'm just trying to see why you would want to start it with 1 instead of just initializing it to be the base and then saying, basically you're multiplying it so, like, so, oh, so that's the point. Okay, yeah, because when we say 5 to the power of 2, that's basically, that's 1 times 5 times 5. So 1 times 5 would be 5 to the power of 1. But I don't like the whole 1 times 5 shit. I'd rather you just say, you pass in the base, and then you say, the base is now I'd rather say a for loop. I guess you'd have total. So you'd have total that you'd initialize to be the base, and then I guess I can write it in a sec. In this case, we're saying, oh, motherfucker. Alright. We have 1. Okay, 1 is 1 times base. Alright, we're assigning to total itself times base. So 1 times 5 is 5. Total is now 1. Increment this from 0 to 1. Now 1 is less than 2. It goes again. So total is 5. We're now assigning to total, excuse me, what it is. 5 times base, 5 again, it's 25. Excuse me. And we're doing the power of 3. And then we're incrementing I, so now I is 2. And now we're saying total is 25. We're now assigning it the value of 25 times the base again, which is 5. So 25 times 5, which is 125. And then we're incrementing I again. Now I is 3. 3 is not less than 3, which is the power that we passed in. And now we're back. So negative exponents doesn't work. But I guess those aren't integers because a negative exponent is 1 over whatever it is, and integers can't be fractional. If you instead initialize total to be the base, and then said for total to be the base, and then for something, let's see, and you say total, and we assign it total times base, and then we say starting with 1 up to the exponent you pass in. So if we start with 1 and we go to 2, then it would be total starts as 5, and total is now 5 times the base, which is 5, which is 25, and then we increment I from 1, which is where we start, to 2. We'll do that. Or we could divide the total by the base, or just leave it 1, and then start at 0. That way, the first power is included in here. But I don't know, it doesn't seem useful to me. It's like 5 to the 0 power is 1. 5 to the 1 power is itself nothing. I don't think I want to calculate that in the beginning. If anything, it's well, it's only one more calculation, I guess. But, okay. So like, so what, for big numbers we do C standard int. Oops. And input output. For int types. Okay. So we'll say exponent. How about we just output this? So we'll say base is 5. Exponent is 3. Cool, unidentified. Oh, exponent is already a function. So what if we say raised to power? What? Oh, never mind. I was just being stupid. I did it again. These need to be ints. We want this to be inline? Well, it would do it anyways. Yeah, we'll have the definition here. So it gets inline expanded if it needs to be. Okay. And we'll say there's an int total. Which will initialize to be the base, and then for int current exponent of 0, or we could start to be 1. Oh, we start at 1 because the power of 0 is 1. Ah, damn, I guess that's what we would do, huh? I guess we would start it at 1, because then we want to get all possible int exponents. So nothing less than 0. Or rather, wait. Yeah, I guess we have to start this guy to be 0. Okay. Why did I do that? From this to is less than the power. And we'll raise current exponent. Okay, so we say passing in 5 to the 3. 5 and 3. Total starts at, oh, probably should be, total is 1. Bro. Oh, how did that disappear? We start with 1. So 1 times the base, that's 5. That's for the first power. Raise it. This is now, current exponent is now 1. And then we're now assigning it 5, which is, so this is now 5. We're assigning this to now be 5 times 5 again, which is now 25 for total. Excuse me, this is 1, now it is 2. Now this is 25 times equals base 25 times 5. This is now 125. Current exponent is now 3. 3 is not less than the power of 3. Boom. Cool. Cool. Yep, which is equivalent to base 0. Should have known. Respond to this real quick. Okay. Answer the retarded question. All right. Yep. Yeah, so if the power is 0, we don't return any products. If it's 1, we return it times 1. If it's 2, we return it times, well, not times 2, but times the base once, or times the base times the base times its times 1 self-multiplied base. So none, it's just 5 versus 2 multiplied bases, which is 25. Boom. We could also decrement it. So let me go in here and do this real quick. We'll count backwards. Need input and output. Or rather, we need output. Rather. There we go. I felt good. Cool. This we'll say 4. If I do this, what will it say? And we'll count down to 0. So we could do 2 ints, starting number int ending number. While starting number is greater than ending number. But we want to count all the way down to it. So I think we'll do less than or equal to. And then we'll decrement. Oh, this is okay. I don't actually have to make a new number. This could be good, maybe. Oh, but we could say current number. We don't want to decrement the starting number. So we could say, for number, and then we start at the number, and we count down to ending number, whatever. Or we could say starting number, but starting number is current number. That way we don't have to, well, we just create one number one time. So maybe that makes sense. But maybe that's a lot of overhead too. Let's just start there. We'll just say this is current number. Okay. Cool. Output the number. So 10. Count from 10 to 0. Okay. For 10. 10 is greater than or equal to 0. Yes. Print 10. Now it's 9. All the way down. 1. 1 is greater than or equal to 0. Print 1. Decrement. And then, yeah, okay. Sounds like this would work. And we'll just do count to 0 from, or count to, we'll just say count to. Count from 2, maybe? Count down? Yeah, because we could have, this could be a function where we say 2 or down or up 2, but this will just be the countdown function. And we'll simply just pass her. Countdown from 23 to 12. Boom. Cool. Okie dokus. Makes sense. Countdown. So like we could do for I don't know, I would do a maybe. Oh, you could have a switch case in here. Maybe that's crazy. You have a switch case in here, and then you have a whole bunch of animations, and then each of the switch cases would, its statement would be to play a specific animation. Or maybe a bunch of cases, and then like every 3 cases, you put that statement. That way, any of these cases do this statement, any of these cases do this statement. And the point would be, you'd be passing in the health of, there'd be a cutscene. And you, well, I guess it would all be animated, but maybe it's a cutscene, and it's all a bunch of separate animations. It's not one huge animation that you play at once. It's actually individual animations where like somebody does something, oh, maybe it's like turn-based animations. So like Baldur's Gate or something like this. But let's say before you're actually playing, you just see it play out and it looks just like regular gameplay. So you want the animations to be piecemeal. You don't want to animate the entire thing at once and then just play it. You want to actually do the calculations and the health and whatnot. And you say, this guy will play this animation. And let's say the enemy attacks, and then we pass in how much damage he does, and then we pass in how much health the receiver, the damage taker, has. And for his health, we check, is his health greater than 0? Is he not dead? Is he alive? Okay, yes, he is. We'll check the case. Or rather, I guess you would just do a regular ass switch statement and you would just pass it in each time. You wouldn't need to do a loop because you wouldn't do subsequent attacks over and over and over again. But let's pretend you did. Let's say it's like 3 attacks on, 3 attacks off. So you do this and then you do a loop for 3. So from 0 to 0 is less, or from starting from 0 until less than 2. So, or until less than or equal to 2. So 0, 1, and 2. And we'll say switch. You're at this health. You take this animation, you have this health, or maybe it's the damage. Maybe if you do a lot of damage, it's a more powerful animation. So you do this much, you do this, you do this much, you do this, you do this much, you do this. So you pass in different attacks. Like you could do, maybe someone casts magic missile. There's 3 little missiles that come out, and then let's pretend you rolled you roll a different die for each missile. So we're trying to determine what the missiles look like. So we do the first, so we pass in how many missiles, okay? And there are 3 missiles, okay? So while we're gonna go from 3 missiles to 0. So while 3 is greater than 0, so that's 3, that's 2, and that's 1. But then 0 is not greater than, so that's it. 3 missiles. So from 3 is greater than 0. So 4, 3, or number of magic missiles, greater than minimum, or greater than no more magic missiles, 0. We do a switch, I guess, and then we'll say roll roll damage. So from 0 to 4, random something, import random, I guess, or include random. I don't know how we're gonna do random. And we get a random number, and then we'll have a switch on that random number, and then it'll be like, oh, you got 1 because there's 1 through 4, so we have 4 different cases maybe. We have 1, and then it is, oh, return this particle effect. It's smaller than the rest. And then, oh, 2 is bigger, 3 is bigger, 3 is bigger. And then we return the damage, and yeah, so we could return the damage. And before that, we set the particle effect. And then boom. So you could do that. You could decrement counting down from things. Okay. Or we could do like Dave Chappelle with a shotgun. He starts with bird shot, and then another bird shot, and then buckshot. Boom. Pepper him nicely once. Hit him again. And then, or I guess he said, what did he say? He'd say, yeah, I guess buckshot at the, is it bird shot, buckshot, and then buckshot, buckshot. I want to listen to that joke again. Let me see. Dave Chappelle. Buckshot. I'll do that later. Why is this guy here, bro? Brandon Fall, dude. Okay. So, we'll say, depending on what the number, there's a switch, and the switch is well, maybe it's print results of my shooting, and we pass in how many shots we fire, and we pass in how many are in the gun, in the shotgun rather, and we know already what the cases are going to be. We know that the 3rd shell is this, we know that the 4th shell is this, etc. So we have a for loop, we pass in how many we're firing, and we go until 0 or until the minimum. So we pass in how many there are, and let's see, and we go until how many there are minus how many we're going to fire. So we pass in how many we're firing, how many are in the gun, and how many we're firing. And we start from, so 4, how many are in the gun, while how many in the gun is greater than or equal to. So if we had 8 and we were firing 4, we'd do 8, 7, 6, 5. 8, 7, 6, 5. So we'll do while shells in the gun are greater than, are greater than shells in the gun minus how many we're firing. And then we will do a switch. Oh, that's the 7th shell. That's this. Do this damage, do whatever. And then, or it'll be this much, or it'll just print, or I guess it's an if, it's not even a case because there's only 2. But maybe we have multiple shells. We have like 4 or 5 different cases, and those are all the cases. Maybe we have, well, there's no default, it's fine. We just know the cases. And then we say, oh, you got a 3. That's the fucking dragon breath buckshot. And then return, decrement, there's now 1 shell less. Now we have 7 currently. 7 is greater than or equal to 4, which is how many we're going to be firing until we have. And then boom, keep on going. So decrementing is also pretty cool. We could do yeah, it works. That's good. All right. Change the value of loop by more than 1 with each iteration. We don't have to do plus plus. We could change it by 2. We could change it by whatever. Whatever, I'm listening to that real quick. If I have to delete it from the video, it's fine. It's whatever. I love Dave. Oh, wait, hold on. No, I want to listen to the whole thing later. I don't want to do that right now. All right, it's in the history. That's cool. So I'm still going to have to mute that part. Okay. We don't have to do that. So we could say, what would be a use case for changing by more than... Oh, we could pass in how many we're doing, but we would have to know that... Oh, we would pass in how many we're changing each time. So we could do... I don't know. Doesn't matter right now. Yes, we could do it with more than that. So, but yeah, we could, I mean, yeah, we know that we need output. Excuse me, and I is greater than 0. We'll start I to be or we'll just say and whatever. We're counting down from the user's number. So we have 10. We'll initialize this to be the user's num, or we could just say, well, I don't actually want to change user num. So yeah, we do initialize it just to be user num. While it's greater than or equal to 0, so we count and actually hit 0, and then we'll count by 3. $10. So we output 10. Alright, so 10 is greater than or equal to 0. We print 10, subtract 3, 7, 4, 3, 1. Don't go any lower. Because it's not greater than 0 or equal to 0. Cool. The perils of the not equal to. While it isn't equal to 10, if something's wonk. And first guess is if something goes wonk and somehow I gets assigned to be greater than 10, then we're going to be stuck with a fucking infinite loop because it'll never equal 10 again until technically we get integer overflow and we count all the way back up from the negative, or if it's unsigned for some reason, then we count back up from 0 to 10, and then it would stop again. But that means we would get like 4.3 billion loops out of it before then, or we just run out of memory or something. But I guess we aren't initializing new shit, we're destroying stuff every time, so maybe we don't run out of memory, we just do it. If it's somehow, yeah, exactly. See, here it is. It's exactly what I was thinking. Former is better. It'll terminate even if it jumps over because it's as long as I is less than 10. So if I is 10,000 somehow and it jumps up there, it still doesn't execute anymore. So if this somehow becomes plus equals 2, boom. Or plus equals, yeah, plus equals 2. And we're jumping over 10 and we start at 1. And then, oh, now we're 3, 5, 7, 9, 11. Oh, now we keep going forever. 13, 15, 17, 19, 21, etc. Yeah, makes sense. Oh, yeah, we accidentally. Okay, so we start at 0. While it's less than 10, we'll do that. So we'll output 0. And if it's 9, we'll add it again. Okay, so basically we count up to 9. And normally we just increment from 9 to 10. But in this case, if it's 9, we actually increment it to 10, and then increment it to 11, and then now it stops. But here, we're at 9, and then we increment it to 10, but then we increment it to 11. 11's not 10. Keep on going. We don't want that. Okay, that makes sense. Oh yeah, people were saying that, or some hiring managers at least were saying that, at least on Reddit, for what that goes. I'm not a Reddit guy, but that's where I go to just get opinions on stuff, or at least to read and see what people have at least looked up, just to find out. And it seems like at least some software hiring managers have seen that a lot of recent programmers, like most people that they've been interviewing, have been having off by one errors. And before I forgot what that meant, but yeah, it's off by one. So if we're saying we want to count down from 10, write a program interviewee to count down from 10 to 0. And then they just do while 10 is, or while the int we're starting from is greater than 0, well then it's going to count 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1 is greater than 0. But then it's going to decrement again and go to 0. But 0 is not greater than 0, so it's not going to print 0. So the program will not do 10 to 0. It will go 10 to 0 plus 1. Or plus whatever your decrement is. So if you're doing counting down by 2, then you'd stop at 2 and not 0. So avoid not equal, prefer less than or less than equal to. Make sense? Off by 1 errors. Yep. 1 too many or 1 too many or too few times. So in this case, okay, we're starting at 1 and we're going till less than 5. Oh, so I'm assuming this is a loop where they want to count to 5, 1, 2, 3, 4, 5, but instead it stops at 4 because it stops at, it only runs while we're less than 5, not up through 5, just like on a number line in middle school or high school or something. I don't remember what the fuck we were using these things for. And if you just do a circle, then it's not included in that line. But if you, oh, I guess it works for graphs too, because we could have like undefined at a certain point where we're not circling, or we're circling but not dotting. I don't even remember that shit really. Yeah, it's supposed to print 1 through 5, but instead it only prints 1 through 4 because we're not using through the number. So we could say at less than 5, starting at 0, or 1 to 5, but we have to include equal. Yeah, wrong relational operator. It can sometimes occur by using the pre or post decrement instead. By using pre instead of post. Or vice versa, or post instead of pre. Okay. Oh, because if we use post, then we're evaluating the number as it is, but then next time increasing it. So we're going to evaluate it again, and then maybe we stop 1 early. Or yeah. Oh, because we don't necessarily have to put in I in there. I mean, maybe that makes sense. We're not making a new variable. Well, I guess we're just doing an expression statement, so maybe it's a waste of time to do that. So we just put in a null statement and then the condition and then another null statement. I would almost prefer, oh, never mind, that works. That works, yeah. Yeah, so from 0, 0 to 10, and then we're doing the incrementing in the statement, then it probably still works fine. It's like we could do okay, and then we could say for int current apples, don't have any apples, and then int total apples 10, and then we could say for null statement current apples is less than total apples. That's it. So there's no, we're not creating any variables. This is the condition, and then we're not changing anything, and then we're simply outputting how many apples we have counted, and we're going to go less than or equal to. That way we count all the apples that we could have. We're outputting current apples. And then we are increasing current apples. Bop. Oh, I gotta sneeze. Oh, so annoying. I hate this feeling. Ugh. Fucking allergies, bro. 51 minutes? Time fucking flew. The fuck? How have I been on this page for so long? Oh. Hair. God damn. God damn. It's the longest page yet. Infinite loop. Or. Yeah, it's basically same as while true. That's what I would guess. Interesting that it defaults to true. But I guess a null statement automatically activates, so maybe we just assume that's true. But it isn't even a null statement, it's just a blank condition. So it's just default true. That an omitted condition expression for a for loop should be treated as true. Okie doke. Avoiding and use while true still. Yeah, it makes sense because it's just more obvious. Like for a newbie, I wouldn't know what the fuck that is. Now I do though. Multiple counters. That way, if anything, like I have multiple resources, and well, there aren't two comparisons. Okay, int x. Oh! We're defining multiple ints, but we should still be allowed to do specifying the types, the two separate types. Define multiple. Can we do multiple resource things? So like maybe I have when either things runs out. Can we do it? So we can say x and y, and then while x is less than 10. So we'll print up through 9. We'll increment it and decrement y. Okay. So we'll print 0 and 9. Yep. Because 0 is less than 10, we'll print 0 and 9. And then now we'll print 1 and 8 all the way up until 9 and whatever the fuck, 9 and 0, I guess. Okay. Interesting. So we could say what would we do? Excuse me. Maybe I'm shooting a cannon, and the cannon it's like a Star Wars cannon on a spaceship, and it has 2 barrels, and each time both have to fire, and I only have 5 heavy rounds, but I have 12 light rounds, and they fire 1 for 1. Maybe one fires faster than the other, and then we'll print until we're out of ammo. And we'll print how much of one and then the other. So we have 10 light rounds and then 7 heavy rounds. And then we'll say int light rounds, int heavy rounds, and then we'll say for, you can do either way, but int I is light rounds, j is heavy rounds, and then we'll say until we run out of ammo, can I do both of these? Can we say light round, or can we say I while it's greater than 0? Because we can't fire again once we have 0. And which would we do? Could we do I is greater than 0 and j is greater than 0? And then minus I and minus j? Oh shit, we can. Why can I not do this part though? Oh, maybe we're just not allowed to do that. So what if I just remove this real quick and then remove j just to test? And then we just say true. Oh, so we can only do integers here, it looks like. What if I did... I'm gonna just, for repetition purposes, do this again in a second. Okay. What if we just do that? It's fine. No parameters, it doesn't do shit. Excuse me. Int x is 0, int y is 0. Oh. Really? I mean, I guess I could do that, but that's kind of gross. Okay, so you have to do, I've never done, I guess I didn't practice that part enough before. Initializing multiple things on the same line. Okay. So we'll do const expression int. We have ammo and then we just fire it all. That's just how it'll go. Int light rounds. 10. Heavy rounds. And we have 4. Cool, and we'll say 4. And I is light rounds. And J is heavy rounds. While I is less than 0. And J is less than 0. If either of those are false, we don't execute. Well, I wonder, is it operating on an OR? Oh, we could say this and J is less than 0, like this. This would be cool. And then it needs an expression, yo. And then errors are cool. Because we have to fire both. So, fire cannons. Both cannons fire at same time. Both cannons must fire at same time. Okay. And then they both fire 1 round, I and J. And here we'll say we print fired light and heavy round. Oh, here we go. I light rounds remaining and J heavy rounds remaining. Bro? What are you fucking bitching about? Line 6, really? Oh, oops. Cool. And then fire cannons. Oops. Light rounds. Heavy rounds. 10 light and 4 heavy remaining. Oh, nope, hold on. Can't print how many we have. In this case, we would actually almost want to do this before, huh? Check that. And then we decrement now, and then we fire. Yeah, so this might be one of those cases where... Bro? Are you a fucking retard? Hello? Oh, there's no... Oh. Oh, I guess this is allowed to continue. Okay, alright. So we'll do... minus I... minus J. I think we would just do minus I and then minus J. 9 and 3. 8 and 2. Yeah, you can fire 4 times. Cool. We could do both of these. If we did a comma, we'd get... Oh, okay, we can actually do both like that. Alright. Fire 1 of each round. Cool. Okay. We could do multiple comparisons, multiple creations, but they have to be integers. No characters up in this shit. What if we did... Oh, we can sometimes. Okay. Yeah. In the same statement and the use of a comma operator. Acceptable practice. Is okay. Okay, and we'll continue with nested for loops in a minute. Let me take a little relaxer.